So in general, volume is going to be calculated by taking a cross-sectional area and multiplying it by thickness. So giving it some thickness. And then for these shapes, we're just going to add up all those area times thickness pieces or integrate. So in this case here, the area A is formed by the x-axis and the function. So this area A is what I've highlighted in yellow. And the function y equals square root of 1 plus sine x. So it's going to look, this function kind of looks like this. And we're going to integrate this, or we're going to find the volume between, the area is between 0 and pi. And we're going to make the volume by taking cross sections that are perpendicular to the x-axis. So this red cross section here. So we're going to take this line here, okay, that red line. That gives us the height of the graph. We're going to take that slice with that kind of length and make a square area from that. So I've drawn the square coming out in 3 dimensions. So that's going to be the square area that's going to generate the volume, and we're going to give that some thickness dx, and then we're going to add that up as we move along the x-axis. Okay, so we're going to integrate along dx. So what does this look like? Well, first of all, we need to write the area function. Area of that square is going to be the height of the graph, or we'll call that y squared. So when we write that out, it's going to be area is equal to the y value of that function is square root of 1 plus sine x. And then squaring it will conveniently get rid of that square root. Okay, so then if I want to find the volume of this, then the volume is going to be the area square root of 1 plus sine x, the height of the graph, squared gives me the area of that square. I'm going to give it some thickness dx, so I'm going to times that by dx, and then I'm going to integrate that or add up those slices from 0 to pi, which is what this question told me. So 0 to pi are my bounds, which were given to me in the question. So once I've done that, I need to just anti-differentiate and find the displacement on the antiderivative. I'm going to rewrite this as 0 to pi, 1 plus sine x dx. Undoing this, we're going to end up with x. The antiderivative of sine is negative cos. So we get negative cos x, and that's going to be from 0 to pi. So my volume then is going to be pi minus cosine of pi is negative 1. So 1 minus negative 1. Okay, and then minus 0 minus the cosine of x, cosine of 0 is 1. So 0 is going to look like that. So simplifying this, I'm going to end up with pi plus 1 or pi plus 2, and that is cubic units. So that is my volume of that object that's going to be generated by those slices.